Now let's talk about why processors are optimized for latency or throughput. So the first question is, why are GPUs throughput focused? And to understand that, we need to see what GPUs do. So GPUs are graphics processors, so they're all about graphics. And to do graphics, the first thing we do is we figure out where all the triangles go on the screen, and then for each pixel in all these triangles, we go through and paint in the color. So how do we compute each pixel? Here are the pixels on the screen. We've got a triangle. For each pixel inside that triangle, we're going to run a program. This program is called a shader, and the program is going to go through and figure out what the color is. So we do that for all the pixels on the screen. Now, there's some nice properties of this. Every pixel is independent. The color of this pixel here can be computed independently of the color of that pixel. I don't have to wait on them. I also have an awful lot of these to do. So I've got millions of pixels on the screen to do at once. So I can process them this way, or I can process them this way. It doesn't matter how I process them because I've got so many to do. So here's a question. What kind of performance do we care about in this setup where we're trying to render graphics to the screen? Well, in this case, we care about latency. Sorry, we don't care about latency, we care about throughput. We don't care about how fast each pixel is. So I don't care if you get me this little pixel over here in the corner really quickly. What I care about is how quickly you can get the whole image. So we care about throughput here. And so this is why GPUs are throughput optimized, because they can do all these pixels in parallel, and what's important is you do lots of pixels per second, not how quickly each pixel is calculated. So why are CPUs latency focused? Well, you can think of this as the basic processing you do is these event interactions. Remember, we had this example with spell checking. So I click spell check and I want to see how quickly can I find the first word. But there are other things that go on there. Key presses, network I/O, it's responding to things quickly. The reason this is important to be latency focused, it depends on the previous thing. You can't go on and do all the other ones until you've finished the ones before that. So let's take a look at an example of how a user interacts with a computer. So how fast can each program run is really the important question. If I'm using PowerPoint, Word, and Firefox, I'm using each one individually. I'm not using them at the same time. So when I go into PowerPoint, I want to get my work done really quickly. Then when I go into Word, I want to get it done quickly, and Firefox, I want to get it done quickly. It takes this long for me to do work in all of these, but I do care about how quickly I get each one done. I don't want to wait this whole time and then say, now all 3 programs are done. I want to quickly get one thing done in PowerPoint before I do it in Word. So this is about the latency of each operation, not the throughput of putting them together. So for CPUs, it's latency focused. And particularly for user performance, it's all about the absolute time from when you do something to get the answer. It's not about how many things you can do in parallel. All right, but of course the real reason for all of this is money. And this comes down to basically software. It's expensive to write and it lasts forever. So software's been around for a really long time and it's very expensive to get anyone to rewrite it. So if you look at the software that's been written for CPUs, it's always been serial. First you do one thing, then another, then another. If you have a fast CPU, you get the best performance. So if I want to take all of this legacy software and make it run fast, then I want to make as fast a CPU as I can, lowest latency. Graphics software, however, has always been parallel. You've always got all these pixels you can do at the same time. So the easiest way to make graphics faster is to do as many things at once, because you already had lots of things to do at the same time. So when we get back to the question why CPUs are latency focused and why GPUs are throughput focused, the answer is simply it's about money. It's the easiest way to get the most money. So the easiest way for Intel to make money is to write processors that run faster, so people's existing software will run faster. And the easiest way for NVIDIA and AMD to make money is to make GPUs that run more parallel, get higher throughput, because they've got more pixels you can do at once, so you get better throughput for your graphics.